Hi students, welcome back to the class. Today we are going to start a new chapter, which is the chapter 6 chapter of part 1, Applications of Derivative. This chapter is quite important because the questions of 6 marks, the long answer type questions are asked from this chapter. So we have already learned 3 chapters, relations and functions, inverse trigonometric functions and continuity and differentiability. But the questions of 6 mark are rarely asked from those 3 chapters. So mainly the 6 mark question, the long answer type questions are asked from this chapter. Okay, and this chapter is also very interesting. After learning this chapter, you will know why do we learn derivatives, where can we apply derivatives, like all those things you will be understand after this chapter. And this chapter consists of 5 exercises. This chapter consists of 5 concepts, and those 5 concepts are rate of change, increasing and decreasing functions, tangents and normals, approximation and maximum minimum. So what is rate of change? It's rate of change of a function at a particular instant. So we have already learned what is this rate of change. So we have already learned the rate of change of a function at a particular point means the derivative of the function at a particular point. This we learned in class 11 while we explained this chapter, limits and derivatives. The rate of change of a function means derivative of a function at a particular point, and that function in application of derivative, that function may be a volume of a sphere, a volume of a cone, or maybe the displacement of a falling object, or it may be the displacement of a moving car, or it may be the profit or total revenue of a business firm. Okay, that function may be anything. The function which we are finding the rate of change at particular instant, that function may be anything, like I told you. Okay, next is increasing and decreasing functions. So increasing and decreasing function. So maybe you are already familiar with the word increasing function and decreasing function. Okay, increasing function means, suppose this is a graph of a function. This is graph of a function, and the graph. Okay, let me draw another graph. Suppose this is a graph of a function. Okay, and this graph, the height of this graph is increasing as we are going from left to right. Okay, the height of the graph is decreasing. Out of this graph is decreasing as we are going from left to right. So if the height of the graph is increasing, or it is rising upwards while going from left to right, then it is said to be increasing function. You can't say this is also increasing function because the height of the graph is increasing. So that's why I told you the height of the graph is increasing from, if you are considering it from left to right. Okay, considering it from left to right, the height of the graph is increasing. That means increasing function. So in this section we will learn about how can we say that this function is increasing without drawing the graph, by the concept of derivative. How can we say this function is increasing in particular interval? This function is actually going up and all. So this is increasing and decreasing functions. Next is tangents and normals. So tangents and normals means, so you have already learned about tangents, right? Tangents means if line is touching a circle at only one point. Okay, this is just touching, it's not cutting. Okay, it's just touching at one point. Right? It's not only for the circles, for any curve. Suppose a line is touching a curve at one point, then we can say this line is tangent to that curve. So in this section, tangents and normals, we learn how to find the slope of this tangent. If the point is given, point and equation of curve is given, then how to find the slope of the tangent. This we already discussed while we are taking the topic Rolle's theorem, right? So slope of the tangent means derivative. Okay, the slope of the tangent means derivative at a particular point. And the concept name is tangents and normals. Normals means the line perpendicular to the tangent which passes through the point. So in order to find the slope of the normal, just we have to take the reciprocal of the slope of the tangent, negative reciprocal of the slope of the tangent. Since these lines are perpendicular, the product of the slope is -1. So you can take the negative reciprocal of slope of tangent to get the slope of normal, right? And finding the equation of tangent, equation of normal, all this comes from this exercise. Finding equation of tangent is also easy, right? If you got the slope and you know the point, so you can find the equation of tangent by Points law form, which you already learned in class 11. Straight lines, right? Equation of lines, right? Next is approximation. Finding approximate value of a function at particular points. Let's take an example. Suppose, what is the square root of 25? Square root of 25 is 5, right? And the root of 25 is 5. So, what will be the square root of 25.3? Okay, so the square root of 25.3 will be 5 point something, right? Answer will be very close to 5, but answer will be 5 point something. So, how will you find that something, that a little value, which will be the difference here? Maybe 5.1 or 5.2, or there will be a little value, right? So, how to find that? How to find the approximate value of 25.3 like this? Okay, so you not only square roots, maybe it can be a cube root, like you have to find, or maybe a fourth root. You have to find the fourth root of 82. The fourth root of 81 is 3, right? The fourth root of 81 means root of 81 is 9, root of 9 is 3. So fourth root of 81 is 3. But what will be the fourth root of 82? The answer will be very close to 3, right? 3 point something. How will you find that a little difference something? Okay, so if you learn this, you can find the cube root or square root or fourth root or whatever of any values. Not any values means values you can find the square root of the values which is close to the perfect square, right? You can find the square root of 26, or you can find the square root of 25 point something, because 25 is the nearest value which is actually a perfect square. Okay, so you can find it by approximations. Next is maxima and minima. This is our big deal, maxima and minima, because the questions of 6 marks comes from will be asked from this topic, maxima and minima, to find the local maxima or absolute maxima. So a point like this, where the graph of the function reaches its top height. Okay, point like this point which we have to find. This point is point of local maxima, and this is maximum value. Or the point like this, minima, or the minimum value, point of minimum and minimum value. So the questions are 6 mark questions are asked from this topic, and in that also the functions may be the volume or surface area or anything, right? It won't be like you are given a direct a function like f of x is this, you have to find the point of maxima. It won't be like that. It will be like the function may be a volume or surface area, as I told you, a profit of a business firm or anything like this, that, and you have to find the maximum and minimum output, right? So let's begin with rate of change. Okay, so let's start with rate of change at a particular example, at a particular instant. Let's take an example. Suppose I have a cylinder, okay, and I am pouring water to the cylinder at a constant rate. So I am pouring water to the cylinder at a constant rate. As I am pouring water to the cylinder, the water level will increase, right? As I am pouring water and pouring water at a constant rate, the water level will increase, right? And the rate of change of height. So the rate of change of height will be equal at any instant of height, right? The rate of change, how fast is the height is increasing, right? So how fast is the height is increasing? That is rate of change of height. So rate of change will be equal as it reaches 4 centimeter as it reaches 4 centimeter or as it reaches 8 centimeter. The rate of change of height will be equal at any instant, since this is a cylindrical shape. Till here, this is a cylindrical shape. So the rate of change will be equal at any instant, right? But what if I am pouring water to this glass? So the rate of change of height won't be equal at every instant, since this the volume is increasing as it goes up. The volume of this shape goes increasing as it goes up. So the rate of change of height won't be equal at any instant, right? At this, as it goes up, the rate of change of height will be decreasing, right? As it goes up, the rate of change of height will be decreasing. At first, the height will increase suddenly because the volume in the lower part is very less comparing to the upper part. So in the beginning, the water level will increase quickly, will increase at greater speed or quickly, and while goes up, the rate of change of height will be lesser and lesser, right? As it goes up, the rate of change of height will be lesser and lesser. So how to find the rate of change of height at any instant? Like I have to find the rate of change when the height is 4 centimeter, or when the height is 5 centimeter, or when the height is 6 centimeter. So the rate of change won't be equal at 4, 5 and 6. It will be different. But in this case, it will be equal at all instants, since this is a cylindrical shape. Till here, this is a cylindrical shape. So at all these points, the rate of change will be same. Here, it won't be same because it's shaped like this, right? So how will we find the rate of change of a function at a particular point? So as we discussed earlier, this is actually the derivative. We just have to differentiate and substitute the value where we have to find the rate of change. Okay, it is rate of change at a particular instant. So we have to substitute a value after differentiating. So first we have to differentiate the function and substitute the value where we have to find the rate of change. Let's do the examples from our NCERT textbook. Then you will get a clear idea about this concept. Okay, let's go for it. Now pause this video, take your NCERT textbook part 1, page number 197, take the exercise 6.1 and read the first question. So this is your first question. Find the rate of change of area of a circle with respect to its radius. The radius r when we have two situations, when radius is 3 centimeter and radius is 4 centimeter. So you have to find the rate of change of area of a circle. So you have to find the rate of change of area of a circle with respect to the radius when the radius is 3 and the radius is 5. Okay, so you have to find the rate of change of area of a circle. Okay, rate of change of area of circle with respect to radius r. So rate of change means derivative. Okay, so derivative, the rate of change means derivative. So derivative of area of circle. So you have to find derivative of area of circles, and area of circle, you know, it is pi r square. Okay, pi r square. So you have to find the derivative of pi r square, and derivative of pi r square with respect to its radius. So with respect to what we are differentiating? With respect to its radius, which is quite important, right? With respect to what? With respect to x, or with respect to y, or what? With respect to what? So we are differentiating it with respect to r. So we have to find d by dr. Since we are differentiating with respect to r, that is why here it is d by dr. If you are differentiating it with respect to x, then d by dx. If you are differentiating with respect to the time, then it will be d by dt, t for time. Okay, so here it is d by dr. So d by dr of pi r square, this is what we have to find, the derivative of area with respect to radius. Or we can simply say we have to find dA by dr, where a is equal to pi r square, both are same. We have to find dA by dr, derivative of area with respect to radius, where area is pi r square. So I have just directly wrote d by dr of pi r square. So we have to find the derivative of pi r square at what instant? We have two situations, at 3 and at 5. Let's find at 3. Okay, at r is equal to 3. So you can write r is equal to 3. So you have to differentiate the function, and after that you have to substitute the value where we have to find the rate of change. Okay, so what will be the d by dr of pi r square? How will we differentiate pi r square? Okay, here r is the variable, so pi is a constant, so pi will be here. Then d by dr of r square, so differentiating r square with respect to r will be 2r. Like we differentiate x, d by dx of x square is 2x. Like that, d by dr of r square is 2r, and pi is a constant, that's why pi is here. Okay, so pi into 2r, this is the derivative. Now we have to substitute r is equal to 3. Okay, we have differentiated, now we have to substitute r is equal to 3. So when r is equal to 3 and r is equal to 3, this will be pi into 2 into 3, right? So 6 pi is the answer. So what will be the unit? 6 pi. This is area with respect to radius. Okay, area with respect to radius. So 6 pi centimeter square per centimeter. So the unit of area is centimeter square and unit of radius is centimeter. So 6 pi centimeter square per centimeter, or if you wish you can cancel this. Okay, 6 pi centimeter. Okay, so this is the rate of change at an instant when radius is 3. So at an instant when radius is 5, you can write by your own, it will be 10 pi. Okay, so let's go to the next question. Now take the second question. Okay, read the second question. The volume of a cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when length of an edge is 12 centimeter? So volume of the cube is increasing at the rate of what? At the rate of 8 centimeter cube. Okay, volume increasing at the rate of 8 centimeter cube per second. Okay, volume increasing at the rate of 8 centimeter cube per second. Okay, volume increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when edge length is 12? Okay, how fast surface area, let SA for surface area, how fast surface area increasing when edge length is, when edge length is 12, right? This is the question. The volume is increasing at 8 centimeter cube per second, and we have to find the rate of change of surface area. How fast surface area is increasing? Okay, we have to find the rate of change of surface area when edge length is 12 centimeter. Okay, so volume is increasing 8 centimeter cube per second. Okay, so rate of change of volume is 8 centimeter cube per second. Rate of change of volume with respect to what? So from the unit we can understand the rate of change of volume with respect to time, since seconds means time. Okay, so dV, rate of change of volume is dV by dt. Okay, dV means rate of change of volume, dt means with respect to time. So dV by dt, rate of change of volume with respect to time, and it is provided, it is 8 centimeter cube per second. Okay, per second, and we have to find how fast surface area increasing. Let us denote the surface area with the letter S. Okay, surface area means S. So we have to find the ds by dt. So we have to find ds by dt. ds by dt at what? At which instant? We have to find the rate of change of surface area at when edge length is 12. Okay, so cube. This is a cube, right? So and this cube, this is the edge length. Okay, this is edge length. So we have to find the rate of change of surface area when edge length is 12. Let us denote the edge lengths with the letter X. Okay, so X is the letter which we are using to denote edge length. Okay, so we have to find the rate of change of surface area when the edge length is 12. Okay, we have to find ds by dt at x equal to 12. This is we have to find. Okay, let us check how we do this question. Okay, so this is dv by dt. You have to find dx by dt. So what is dx by dt? ds by dt. So before that, what is S? S is surface area. And what is the surface area of the cube? The surface area of the cube has 6 surfaces which are in squares. So 6 into x square, which you have already learned in class 9 or class 8. So this is the surface area. So ds by dt means derivative of this. Okay, ds by dt. So why ds by dt? Okay, why with respect to time? Here it is asked how fast the surface area is increasing, right? How fast the surface area is increasing, and it is not specified to with respect to what we have to differentiate. Like in the previous question, it was specified. We have to find the derivative of area with respect to radius. That's why we found dA by dr. That in that case, you are asked to find the derivative of area with respect to radius. Here it is not specified with respect to anything. If it is not specified with respect to what we have to differentiate, we can take it as with respect to time while doing the questions in rate of change. Okay, if it is not specified with respect to what we have to differentiate, you can take it as with respect to time. Or it is asked how fast. The how fast area is increasing means the fast and slow we are comparing with respect to time, right? How we say it is fast or it is slow, we are comparing it with respect to the time. Okay, so we can differentiate it with respect to time. If it is specified that how fast the surface area increasing with respect to its edge length, means then you have to differentiate ds by dx. If it is specified, you have to differentiate it with respect to the edge length. But here it is not specified, so I am taking it as with respect to time. So ds by dt. So s is equal to 6x square. You have to find ds by dt. That means d by dt of this 6x square. S means 6x square, right? So d by dt of 6x square. How will we differentiate 6x square? So derivative of 6 is constant. I am writing 6 here. So x square derivative will be 2x, right? So 6 into 12x. So 6 into 12x, but it is not over yet. So derivative of x square is 2x, but we are differentiating it with respect to t, not with respect to x. So derivative of x square will be 2x into, then there will be derivative of x, right? So 2x into dx by dt, right? Suppose we are differentiating it with respect to x, then 6 into 2x or 12x is enough. But we are differentiating with respect to the time. So there will be dx by dt. Remember, we learned d by dx of y square. What was the derivative of y square? It will be 2y. Then there will be derivative of y, which is dy by dx. So answer will be 2y into dy by dx. Right. So the d by dx of sine y. Here it is y and here it is x. So derivative will be cos y into dy by dx. Right. Like that. Here it is x. The function is depending on x, and you are differentiating it with respect to t. So here will be a dx by dt. Okay, it ends up with dx by dt. So 6 into 2, 12x into dx by dt. This is it. 12x into dx by dt. So you are asked to find the rate of change when x is equal to 12. At an instant when x is equal to 12. That means we can substitute 12 at the place of x. But what will we substitute at the place of dx by dt? It is not provided. Okay. The rate of dx by dt is not provided. Dx by dt means rate of change of edge length with respect to time. It is not provided in this question. Okay. So rate of change of edge length is not provided in this question. So we have to find dx by dt before we go into this. So it is given dv by dt is equal to 8 centimeter cube per second. So we can find dx by dt from this. We haven't used this information yet, right? So dv by dt, what will let this be here? Let this be equation number 1. Okay, this will be here. Okay, now we'll go to this dv by dt. dv by dt is 8 centimeter cube per second. Now what is v? S is 6x square and v volume is x cube. Volume of the cube is x cube, right? So d by dt of x cube is equal to 8, and d by dt of x cube, derivative of x cube is 3x square, and as I told you, there will be a dx by dt. Okay, this is 8. So dx by dt will be 8 by 3x square, 8 over 3x square. So this is dx by dt. So we can substitute this dx by dt right here. Okay, so this our ds by dt, ds by dt is equal to 12x into dx by dt, which is 8 by 3x square. So we can cancel this. So 12 into 8 by 3 into x. So this is our ds by dt. ds by dt, rate of change of area, surface area with respect to time. And we have to find it at an instant when x equal to 12. So you can substitute x equal to 12 right there. So x equal to 12. So cancelling this 12, the answer will be 8 by 3. And what will be the unit? Unit ds by dt, rate of change of surface area with respect to time. That means centimeter square for surface area and s for the time. Okay. Now let's move on to the next question. Now let's read 5th question. A stone is dropped into a quiet lake and waves moves in circle at the speed of 5 centimeters per second. At the instant when radius of the circular wave is 8 centimeters, how fast is the enclosed area increasing? That means there was a quiet lake, which was a peaceful situation, and we just dropped a stone into it. And what happens is waves moves, right? Waves formed, and the waves moves in circles, right? The waves is moving in circle, and we have to find the enclosed area of the circular wave at an instant when the radius is 8 centimeters, right? So suppose we have a quiet lake and we drop a stone into it. So what will happen is waves will move, right? Waves will move like this in circles. Okay, a circle, that means a circle is getting, there will be a circle whose radius is increasing and increasing, right? A circle which will be like this. Okay, so not like this, it won't break, it will be like this. So the a circle is, the size of the circle is getting increased. That means the radius of the circle is increasing, right? Okay, so the waves is moving at the speed of 5 centimeter per second, right? And the waves is moving at the speed of 5 centimeter per second means dr by dt. Okay, it is the rate of change at which the radius is increasing, right? The wave is moving, that means the radius is increasing. Dr by dt is equal to 5 centimeter per second. I don't remember where the value was actually 5. I'm taking it as 5. If it is not 5, we can change the value. Okay, so dr by dt is equal to 5 centimeter. Okay, we have to find how fast is the enclosed area increasing. So you have to find the rate of change of area, and it is not specified with respect to what we have to differentiate, with respect to radius or with respect to something else. So while it is not specified, you can take it as with respect to time. So you have to find dA by dt. Okay, so you have to find the rate of change of area of the circle with respect to the time at an instant when r is equal to 8 centimeter. Okay, you have to find the rate of change at this instant. And this also, I am not sure whether the value was 8 or not. Okay, you can take 8, or if you wish you can change that value. So dA by dt of a, while a is equal to pi r square, right? So derivative of pi r square. Derivative of pi r square is d by dt of pi r square. So what is it? D by dt of pi r square equal to? No need of this. So pi r square derivative is the pi is constant. R square derivative is 2r into dr by dt. As I told you, there will be derivative of r. So 2r into dr by dt. So question is quite direct. You have to find the derivative at an instant when r is equal to 8 centimeter. So you can substitute 8 here. So pi into 2 into 8 into dr by dt is given, that is 5. Okay. So answer is 5 into 2, 10, 80 pi centimeter square per second. This is the unit, right? Yes, it is right. So this was the fifth question, which was quite easy. Most of the questions are quite simple. So I'll be doing only the tough questions. Okay, let's move to the next question. Okay, now read question number 10, which was a ladder of 5 meter long is leaned against a wall, and the foot of the ladder was pulled along the ground away from the wall at the rate of 2 centimeter per second. Then how fast is the height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? So this is our 10th question. So this is ground, this is a wall, and this is a ladder, right? Okay, and the length of the ladder is 5 meter. Ladder of 5 meter. Okay, and the foot of the ladder is pulled along the ground. We are pulling the foot along the ground. Okay, in this direction, not like this. Okay, so we are pulling it along the ground at the rate of 2 centimeter per second. So obviously the height of the ladder will decrease, right? It will drop from here. Okay, so if we are pulling it at the rate of 2 centimeter per second, so at what rate the height on the wall will be decreasing? At the instant when the foot is 4 meter away from the wall. When this distance is 4 meter, how fast is it will be the height on the wall will decrease. Okay. So imagine how fast it will be decreased. So suppose you don't know. Suppose I am asking this to a common man, that you are pulling the foot of the ladder at 2 centimeter per second. The height will obviously decrease. Will it decrease at the greater speed than we are pulling, or it will decrease at a lower speed? Okay, and pulling it at the rate of 2 centimeter per second, will it come down at a greater speed, or greater than 2 centimeter per second, or will it come down slowly? Okay, what will be the answer? This is just I am asking this to a common man, not to a +2 student. Okay, what will be the answer? Just think. Okay, so answer will be different. You can ask to anyone, like you can ask to anyone who doesn't know about differentiation and all. You can ask to anyone. Okay, the answer will be different, because if it is like this, like this distance is lesser than this distance, at this if this equation is like this, the height will decrease in a lesser speed, right? If it is like this, it will fall down all of a sudden. It just need a small touch, it will fall down. That means the height will be decreasing very quickly. Okay, so we have to find, that means it is different at every instant, right? At this instant the rate of change is different, at this instant the rate of change is different, at this instant the rate of change is different. This is the application of rate of change, because at every instant the rate of change won't be same. Okay, this is a clear example for that. So we have to find the rate of change at an instant when 4. Let us see this mathematically. Let us modulate this mathematically. Suppose this distance is x and this is y. So x is changing, right? X is changing at 2 cm per second. That means dx by dt is equal to 2 cm per second. We have to find dy by dt. We have to find dy by dt. So how fast the y is changing, that is what we have to find. We have to find dy by dt, and we have to find dy by dt at x is equal to 4. Okay, at an instant when x is equal to 4. Okay, so how will we find that? And x is equal to 4 meter. Okay, x is equal to 4. This is centimeter and this is meter, right? So let's do. So we have a connection here. X square plus y square is equal to 5 square by Pythagoras theorem, right? X square plus y square is equal to 5 square, which is 25. Okay, now we will differentiate this function, this implicit functions. Since there is x and y, this function is implicit, right? So x square plus y square equal to 25. We will differentiate this with respect to time. Okay, so what we are getting is, on differentiating this with respect to time, we have 2x into dx by dt, okay, plus y square derivative will be 2y into dy by dt, equal to derivative of 25 will be 0, as it is a constant. The constant won't change, right? So 2x into dx by dt, 2y into dy by dt equal to 0. So let's substitute all the values. Dx by dt is equal to 2 cm per second. So 2 into 2 cm per second. Okay, sorry. 2 into, at the place of x we can substitute 2 into at the instant x is equal to 4, right? When the distance is 4. So 2 into 4 into, and dx by dt is again 2. So 4, it's in meter. So we have to convert this to centimeters. So let us write this 4 into 100. Okay. So 2 into 4 into 100. So I just converted this to centimeter. 2 into 4 into 100 into 2 plus 2 into y into. So what is the value of y? Since x square plus y square is 25 and x is equal to 4, then y will be at that instant, y will be 3. Okay. So 2 into 3 into, not 3, 3 into 100, right? 300 into dy by dt is equal to 0. Now we have to find the value of dy by dt. You have to find this. Okay. So I am writing here dy by dt equal to, taking all these things to the right side. So 2 into 4, 8, 8 into 2. So 2 into 4, 8 into 2, 16. Okay, 8 into 100. Sorry, 16 into 100. 16 into 100. So here also there will be 100. That's why I am not multiplying with 100. Okay, this divided by this value. So this is 6 into 100. And there will be negative as this goes to the right side. Okay, so 100 and 100 will be cancelled, and simplifying this answer will be minus 8 by 3. dy by dt, the unit will be centimeter per second. So answer is minus 8 by 3 centimeter per second. But you have to write the height on the wall is decreasing at the rate of 8 by 3, not negative 8 by 3. Since here is a negative sign, so you have to write height on the wall is decreasing because of this negative sign. And you have to write height on the wall is decreasing at the rate of 8 by 3. You have to not minus 8 by 3. Again, you don't have to write negative. Okay, the height on the wall is decreasing at the rate of 8 by 3 centimeter per second, not increasing. Okay, so this is it. We will move to the next question. Now moving to the 11th question. The 11th question is, a particle is moving along the curve 6y is equal to x cube plus 2, and we have to find the points on the curve at which the y coordinate is changing 8 times as fast as x coordinate. So we have a curve 6y equal to x cube plus 2. So this is your axis, coordinate axis. 6y equal x cube plus 2. So you don't know, maybe you don't know to plot the curve, and there is no need of it. But if you know it, it's good. Okay. So since x cube is this, 6y equal x cube plus 2 will be 2 unit above this, will be a little difference, but somewhat like this. Okay, and it is not important. Okay, curve will be like anything. So this is, suppose this is the curve 6y equal to x cube plus 2, and a particle is moving, or suppose there is a point, there is a moving point. The point is moving through this curve. So as the point moving, the x and y coordinate of this point will be changing, right? As it moves, the x coordinate will change. Okay, and obviously the y coordinate will change. So we have to find some points on this curve. Okay, some point on this curve where the change of y coordinate is 8 times as fast as x coordinate. Okay, a change of y coordinate and change of x coordinate is not always same in every point, right? Suppose we have a curve like this. Okay, suppose we have a curve like this. Okay, at this point, in this intervals, the x coordinate will be changing fast, right? While it goes up, the change of y coordinate will be greater than x coordinate while it is going vertically, right? Like that, the change of x coordinate and change of y coordinate won't be always same, right? So we have to find the point on this curve. The change of y coordinate is 8 times as fast as x coordinate, right? So that is change of y coordinate is dy by dt. So change of y coordinate, this should be 8 times the change of x coordinate. So we have to find a point like this, dy by dt equal to 8 times dx by dt on this curve. Sorry, I forgot to write the equation. 6y equal to x cube plus 2 on 6y equal to x cube plus 2. So simply we can differentiate that function. So since 6y equal to x cube plus 2, while differentiating this relation with respect to time, you will get 6 times dy by dt will be 3x square dx by dt. Okay, this is for all points on this curve. 6 dy by dt will be equal to 3x square dx by dt, and we will compare these two equations. Here dy by dt equal to 8 times dx by dt. So in place of dy by dt, you can substitute this 8 times dx by dt. So 6 into 8 times dx by dt will be equal to 3x square into dx by dt. And here dx by dt will be cancelled, right? So 6 into 8 is equal to 3x square, and solving this you can find x, means you can find the x coordinate of that point which is required. Okay, so x square will be equal to, let us take this 3 to this side, so 6 into 8 by 3. So cancelling this, 2 into 8, 16. So x square equal to 16. X square equal to 16. So x is equal to plus or minus 4. So we have to take plus 4 and negative 4. Means it can be negative, right? X is the coordinate, and the coordinate can be negative at any time. Suppose this x is edge length or x is radius or something like that. So as we know, it is length, it can't be negative. So we can neglect the negative values. But in this case, since it is a coordinate, we can't neglect it. So x is equal to 4 or negative 4. Then in order to find the point, we have to find the coordinates. We have to find the y coordinate also, right? So let us substitute this 4 at this place. So 6y is equal to 4 cube plus 2. 4 cube plus 2, and 4 cube is equal to 64, right? So 64 plus 2 is equal to 66. So 6y is equal to 66. So y is equal to 11. So 4 comma 11 may be one point where the change of y coordinate is 8 times as fast as this coordinate. Now let us substitute negative 4 at this place. So 6 into y is equal to negative 4 the whole cube plus 2. Negative 4 cube is negative 64. Negative 64 plus 2 is negative 62, which is 6y. So y is equal to negative 62 divided by 6 minus 31 by 3. So negative 4 comma negative 31 by 3 is the next point. These are the required points. Okay. Now let's move to the next question. I think two more questions will be enough, right? So let's move to the next question. Next, we are going to discuss the question number 14. So, read question number 14. The sand is pouring from a pipe at the rate of 12 centimeter cube per second. So, we open the pipe and the sand is pouring from the pipe. The sand is pouring from the pipe at the rate of 12 centimeter cube per second. And the falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. So when the radius is 60, the height is only 1/6 of that. That means the height will be 10. Okay, like that. The radius is 60, the height will be 10, 1/6 of that. So the falling sand forms a cone on the ground that the height is always 1/6 of the radius of the base, and you are asked to find how fast is the height of increasing. So you have to find the rate of change of height at an instant when height is 4 centimeter. Okay. Okay. We have a pipe. Suppose we have a pipe. Okay, pipe. This is a tap. Okay. And sand is pouring from it. Right. And the pouring sand just forms a cone on the ground. Okay. Like this. The falling sand forms a cone on the ground in such a way that the height is always 1/6 of the radius. Means height is always 1/6 of r, radius by 6. The height is always 1/6 of the radius. So we have to find the rate of change of height when the height is 4 centimeter. Okay. So we have to find the rate of change of height and it is given that the volume is changing at the rate of 12 centimeter cube per second, right? It is also provided. 12 centimeter. This is the rate of change of volume. We have to find the rate of change of height at an instant when h is equal to 4. This is our question. Okay, rate of change of height when height is 4. Okay, and provided h is equal to r by 6. Because the volume is depending on height and radius, that is why it is given the connection. The volume of the cone is pi 1/3 pi r square h. So the volume is depending on radius and height. So you are provided this connection. Now the volume is pi by 3, means 1/3 pi r square into h. Here we can use this connection. For h we can write r by 6, or for r we can write 6h. But what is better? Writing h is equal to r by 6 or r is equal to 6h. It is better to write r is equal to 6h since we are asked to find dh by dt. That means the function should depend on h. Okay, we have to express this function in terms of h. Then only we will get dh by dt. If it is depending on r, we will be getting dr by dt. Then we have to simplify and again we have to go for dh by dt. Okay, so let us substitute r equal to 6 as this function. So pi by 3 is equal, so v is equal to pi by 3 into 6h whole square 36h square into h. So 36h cube, and cancelling this you will get 12 pi h cube. This is the volume. This is volume. So dv by dt equal to 12. dv by dt means rate of change of volume. Rate of change of volume with respect to time. So let's differentiate it with respect to the time. So 12 pi is constant. Let us write it over here. H cube derivative will be 3h square into dh by dt. 3h square into dh by dt. Okay, and we have to find this dh by dt. Okay, and what all things are provided? dv by dt, it is provided 12h at an instant h is equal to 4. So let us substitute here. So 12 is equal to 12 pi into 3 into 4 square into dh by dt. So this is what we have to find. We can cancel this 12 together and we'll take this thing over here. So what answer will be 4 square is 16, 16 into 3 48, 48 into pi, 48 pi. So answer is 1 by 48 pi. dh by dt equal to 1 by 48 pi. All the questions are quite simple, right? 1 by 48 pi. This is the answer. Let's move to the last question. Okay, this time let us do an example questions, which is in page number 197, example 6. Okay, and the question is the total revenue in rupees received by the sale of x unit of a product is given by r of x is equal to. So total revenue is provided with an equation. R of x is equal to 3x square plus 36x plus 5. Find the marginal revenue. You are asked to find the marginal revenue. So marginal revenue when x equal to 5 and it is provided that whereby marginal revenue we mean that rate of change of total revenue with respect to X. So the question is very simple. The marginal, we are asked to find the marginal revenue, and marginal revenue means rate of change of total revenue with respect to X. And the total revenue, it is provided R of X is equal to 3x square plus 36x plus 5. This is R of X. We have to find the marginal revenue. Okay, let us write it as M of X. Okay, and marginal revenue, this is what you asked to find, and this provided that marginal revenue actually means the derivative of total revenue. Okay, d by dx of R of X. Okay, with respect to X. So that's why d by dx. At an instant when X is equal to 5. Okay, so this is our last question. Let's right. So just we have to differentiate this. 3x square derivative will be 6x. Derivative of 36x is 36, and then we have to substitute. This is actually derivative of this, or you can write m dash of x. M dash of x means derivative of this. At instant 5, let us substitute 5. M dash of 5, or 6 into 5 plus 36. 6 into 5, 30 plus 36 is equal to 66 rupees is our answer. This is our marginal revenue. So this was the last question. And the similar question exercise also, you have to find the marginal revenue or marginal cost. Where the marginal revenue or marginal cost, both are the rate of change of total revenue or total cost. Okay, so you can do the rest of the questions. So our today's topic is over, rate of change. Next day I'll come up with a new topic which will be increasing and decreasing function. Okay, till then, bye bye.